50 years ago, we went to the moon. We called it Apollo.
What many people don't know is that Apollo had a twin.
She was a woman named Artemis,
goddess of the moon.
We are returning to the moon
as a new generation of explorers.
This time to stay.
And to prepare to achieve humanity's next giant leap of sending the first human missions to Mars.
We believe our course will redefine what is possible.
That we would discover life-saving,
earth-changing science.
And that the challenges ahead will inspire generations.
This is our manifest.
For all who wondered if we could return.
For all who dreamed of pressing beyond.
This is your calling.
We go for all of America.
We go.
We go as the Artemis generation.
We go.
Hello, everyone. I'm Atlas with the Gwinnett County Public Library, and welcome to a very special GCPL live stream with a NASA Artemis team member. Today, we will be meeting Laura Poliah, an Orion test engineer. Laura performs Orion spacecraft system testing at Kennedy Space Center, Plum Brook Station, Ohio, and Waterton, Colorado. Testing includes applying acoustic, vibration, thermal, and structural environments to Orion spacecraft, as well as performing end-to-end testing across the spacecraft and ground systems to ensure it is qualified to go into space. If, during her presentation, you have any questions for Laura, please comment below and we may be able to answer it live during our stream. All right, Laura, please take it away.
Hi, my name's Laura Poliah, as Atlas mentioned. Today I will be talking to you about NASA and the Artemis missions and going to the moon and Mars and beyond. So if you could bring up the first set of charts. There we go. All right. So NASA, we were founded in 1958. And it is a government agency. Right now, we have about 10 centers across the U.S. And I'm going to specifically talk about the Kennedy Space Center. Is where I work at. All right. All right, so if you go to the next chart, specifically my role at KSC, as Atlas mentioned, I am a test engineer. I specifically work on the Orion spacecraft. The picture that you see up there on the right-hand side is the spacecraft integrated together. So the crew module, which is the top half, that's where the astronauts are actually going to be housed in and taking them on their journey. And then the bottom half is a service module, in where that's really providing the commodities to give the astronauts what they need to be in space. And specifically, I work on performing the tests on the spacecraft, both flight software and hardware, to ensure that it works as an end-to-end system, as well as ensuring that it's qualified to perform in the different environments it's going to experience during launch, the mission in space, and then also recovery. So as Atlas mentioned, there's testing that happens, that it's going on. That's things like the stiffness and modal test. So that's, you're applying loads to different parts of the vehicle and you're seeing how it's going to react to those loads. I do acoustic testing. This is where you're applying different sound levels that the vehicle is going to experience during launch. There's a lot of sound that's coming back from the propulsion systems that you need to know that the vehicle is going to be able to withstand. There's also the thermal testing that we do. Obviously, space, you experience very extremes in the hot and then the cold. And we need to make sure that while it's experiencing that, in addition to the vacuum of space, will all the equipment still be working as it's supposed to be. And on top of all of that, when we're doing that testing, if we do identify any issues that's going on, then we report those issues to our program management and we work to decide what are the recommendations that we need in order. Is it safe to still fly on the vehicle? Do we use it as is? Do we repair it? and what's those steps to proceed forward. I have some videos on here and pictures of what we do. There's basically, not a lot of people know this, but we actually have 2 articles that we work on for testing. There's the flight article, which is on the left-hand side, that's actually going to go into space and experience the mission of the Artemis 1 mission. And then there is the second side, which is our structural test article. And that's where we really perform a lot of the higher level tests that we perform on. So like if something does go wrong and the hardware maybe doesn't perform as was expected, then we're not risking the flight article that's associated with it. So for the structural test article, there's 2 videos on here, which I always think are fun. Both of them are Pyroshock videos. The first one is our SAJ jettison. So you could go ahead and play that video. This is testing to see if the bearings that are going to come off during launch and going into space. So they need to come off first, and then it exposes the actual Orion spacecraft into space, and it continues on. And that was showing that that it is jettisoning correctly, and that and we measured the responses that came back from that shock, and making sure that it didn't affect any of the heart of the systems that were on the vehicle. The next one is actually our drogue mortar pyroshock test, and you can go ahead and play that one. This one's associated with actually when we're coming back and we're re-entering into Earth's atmosphere, and the vehicle is going very quickly, and it's dropping altitude at a very quick pace, and you need to deploy the parachutes in order to slow it down. This is testing the deployment of the canisters to allow the parachutes to come out. So this is actually deploying those canisters, and you kind of see that in slow motion, and then seeing how, again, that response affects the vehicle and the systems that are there. So that's kind of at a high level the different tests that we do and what I work on specifically. A lot of people do ask, you know, how do you get to become a test engineer? What's your background? What education did you get? So I'm going to talk a little bit about that. I did go to the University of Central Florida in Orlando, Florida. While I was there, I earned my bachelor's degree in aerospace engineering and my master's in mechanical engineering. I also participated in a lot of activities and in groups. Specifically, I was in AIAA and Sigma Gamma Tau, which allowed me to network with a lot of people, which I think is very important, and really get to meet other people in the field and learn about different things that are going on in the degree that you're seeking. So I always feel like it's very important that you're looking for those opportunities to get as much experiences as you can. The next one I had on that picture is when I was performing. It's me with a little laser there and my teammates, and this is where we were doing some non-destructive testing. And this is where I really got into the testing realm. And we here in this one in particular, we were trying to find out a way to be able to test the stresses and strains on a piece of hardware without needing to put applications on it, that you're able to use a laser on that vehicle. So that was a very good experience to not only work with my college peers, but also work with instrumentation and which was the MTS team, and get to work with them. Then while I was actually still in school, I was looking for opportunities to get more experience, as I mentioned. So then I started working as a contractor in the NASA related field. And that's when I started working on interfaces with the vehicle. So that's kind of that picture with the vehicle itself. That's the integrated SLS with Orion on top. And then you kind of see there, I don't know how small it is that you guys can see that, but there's the Orion systems and the ground systems, and then you're talking about the different what's flowing between the two and what's needed to really interface between each other. And I got into the requirements and design aspect of how the hardware works with facilities that help it launch from from the Kennedy Space Center. And so you start getting into the power and fluids and the propulsions and seeing exactly what it takes to process and launch a vehicle here at the Space Center. In addition, I also worked on the altitude chamber that hadn't been used since Apollo days, when they were working on the crew module and checking in the vacuum temperatures how it was going to be exposed. I started working on the reactivation of that chamber for the Artemis mission, and that also helped with the background of learning what it takes from a facility perspective in order to get that vehicle ready and tested to be operational. So now that you know a little bit about me, how I got to be where I was and what I do, now I'm going to talk to you a little bit more about the Artemis mission, specifically our return to the moon. We are going to the moon. We're preparing, which then will take us to prepare to go to Mars. We are doing the first step of many, many steps forthcoming to go there. The first one is Artemis 1. The name Artemis kind of stemmed from the fact that Artemis is the twin sister of Apollo, and that's where we're gonna plan by 2024 to have boots on the moon, and you're gonna see the first woman and the next man to step onto the surface of that moon. The next, sorry, if you go back one. Yeah. So that path for Artemis 1 that you're going to see is that in terms of trajectory, we're going to come out from the Earth, orbit around the moon twice, and then come back to Earth. And that's really going to be our demonstration for proving, and the proving ground and the basis for all the next Artemis missions is going to demonstrate that we can integrate the vehicle together from the ground systems launch and test and demonstrate the different aspects of the vehicle, and then also make sure that all the mechanisms are really working. The next chart goes into how are we going there, and as I mentioned, we're testing out all these things, but there are three main programs that we're working with. There's exploration ground systems. That's where the facilities that we're using to process and build and launch the vehicle. There's a space launch system itself, which is the launch vehicle that's going to take the spacecraft and the astronauts into space. And then there's the Orion spacecraft itself, which, as I mentioned, is going to hold the astronauts, house them, and take them into the path that they need to go to. So that's the methods how we're going to go there. So now I'm going to go into a little bit about the exploration ground systems at the Kennedy Space Center. Again, they're focused on building, launching, and recovering the hardware itself. And to start off with, I'm going to kind of go through some of the main sections of the vehicle, of the Space Center and the ground systems, and talk about what they work on. The first one is the vehicle assembly building, and this building is big. You go to the next chart to kind of talk about some specifics here. It is 425 feet tall. It's one of the largest buildings in the world by area. It's where we assemble all the parts of the vehicle, including the SLS parts, the core stage, the booster, the upper stage, as well as Orion, and we start integrating it vertically and then roll it out to the launch pad. So this facility is very important. It helps keep the vehicle safe from the outside environments, as well as giving us a good opportunity to integrate the vehicle as well. The next chart, so I mentioned it getting integrated in the facility. What it gets integrated on is the mobile launcher. There are numerous amounts of parts and pieces that come to the mobile launcher. And it starts off inside the VAB, and it is transportable. So we have a vehicle that then moves the mobile launcher to the pad and then back again. But the mobile launcher is what provides all the commodities that the vehicle itself needs, and we try to be as reusable as we can, and so that it could be transported and back. So I mentioned the vehicle that transports it. You go to the next chart, and that's actually the crawler that that it's called is the crawler transporter. It is a massive machine that that weighs about 6.6 million pounds, and it can carry over 18 million pounds on there. It doesn't move that fast. It's about an exciting 1 mile per hour. It moves, but it does take the vehicle where it needs to go, and it takes it safely. And we actually had to have specific in the pathways, specific rocks put down as to be able to withstand the crawler and how it's moving and how it moves. Yeah. The next chart is out at the pad. So this is where the crawler takes the mobile launcher and the integrated vehicle, and it's the final stop as last spot on Earth. It's considered a clean pad, which means that not only can it be used for Artemis missions with the SLS rocket, but it can support other missions from other companies who may wish to launch rockets. There are several components from the pad itself. You can kind of see the lightning towers. There are 3 of them in where that's used to direct lightning away from the pad to protect it. It does stand over about 600 feet tall. And then we do have the flame trench, which is below the picture there of the mobile launcher. That's where essentially it can withstand the temperature from the launch and the propulsion systems, and it withstands temperatures of 2200 degrees Fahrenheit. Then we have the water tower. This water tower holds roughly 400,000 gallons of water. And it's essentially used that when we are launching, there's a lot of sound suppression that's needed and ignition over pressure. And it's flowing 1.1 million gallons of water per minute into that area. So it's helping dampen that acoustics and affecting that vibration back into the vehicle. And so those are basically the component. We have one more. The Launch Control Center is very important. It's finally essentially where it's the hub of the operations at KSC. It's extremely important because this is where we're monitoring all the systems on the vehicle, and we're saying that we're good to go for that launch. Our launch director will be here, and this is Charlie Blackwell Thompson. She's actually our first female launch director. And she's been working with a great set of team to make sure that this room is ready to go and that we're all knowledgeable of all the systems. So I think we have one more video in where we're going to kind of show the simulation of that launch. Okay, I wasn't sure if they could still hear me. Okay. So T-minus 10 minutes, that's essentially, we're saying, picking up from the rockets at the center of the launch pad. Again, the Launch Control Center, you kind of see off in that far off right how far we are away. And we're looking at the systems and we're ensuring that it's ready to go. We've fueled the tanks and made sure that they are at the right operating temperatures. We're ensuring that all the communications are happening between all the systems, and again giving that go no go. You can see the trajectory right there that it was just showing, and that's retracting the crew access arm. And now for Artemis 1, it won't be crewed, but for Artemis 2, it will be crewed. So in this case, for Artemis 1. Now this is the ignition that's happening for the vehicle. Flame trench coming through, withstanding those temperatures.
5, 4, 3, 2, 1. Booster ignition and liftoff.
And then it's liftoff, being propelled by the propulsion systems on the booster and core stage. And then it starts separating as we're launching. Boosters come off first. And then those are the SAJ fairings I showed you earlier in the test video being jettisoned off. the engine cut off. Then you have that upper stage called ICPS. It's going to deploy it to the right trajectory. And then you just have Orion and the service module continuing on to the moon. And that's how that mission profile would look moving forward. So that's essentially what we're trying to achieve once we go to the moon, boots on the moon by 2024. By 2028, we're looking to have a sustainable environment and missions going to the moon. And then a decade later is when we're looking to be able to reach Mars in that time frame. So that's essentially our timeline, and the time is now to start getting there. So I guess we can go to the questions if there are any.
Sure, thanks for that, Laura. We did have a few questions that were posted to our event listing, and I will go ahead and jump into a few of those if you're okay.
Great.
So Manor wanted to know, as a test engineer, what are some of the things that could cause issues for the Orion spacecraft that would make it unfit to use? Is there anything that could cause the mission to be postponed for any reason?
Yes, so kind of as I mentioned, we do perform these functional and performance tests on all the systems that we have. And when you're performing those tests, you're checking to see does that hardware act like it's supposed to, and there can be instances in where the hardware doesn't necessarily turn like it's supposed to, like valves opening, or we do leak checks in where we're making sure that the propulsion tanks, for example, if there are leaks there, then it could be very it could be a loss of mission. And so there are instances in where we can have issues that cause the spacecraft to be unfit to use. Now, as I mentioned earlier, we assess each and every issue that we run into during tests, and we determine, can you repair it? Can you use it as is? And we look at all the risks that are associated with that to say, do they still meet the requirements that we had laid out at the very beginning? And are there any risks to the hardware, to the mission, and to the crew life? And those are all things that are taken into account. And based on those discussions with management from all levels up to the to our highest management, then it will be determined that we could be postponed for that reason. And so, examples would be things like our environmental system. If there's a big issue with the environmental system and it means that there's a high risk to crew, then that's unlikely that we would go for launch that day. We would have to figure out what happened and then proceed from there.
Okay, thank you. Let's see. Christina asks, what kind of technologies will be used to learn more about the moon during the Artemis missions?
So there's a lot that we're going to use as an opportunity to test out and see what we can achieve at the moon, in hopes for helping us build a better basis for what we can do at Mars. There's going to be a lot of in situ testing that we're going to try. So it's things like what can we use on the moon in order to help us build up in the environments we need to be in. So we're going to look for things like 3D printing. We're going to look for recycling water, recycling air, and then seeing what type of material we could use from the moon and utilize to then build further on. We're also going to probably be testing out the spacesuits and seeing how those interact from the space station to the moon. And then it'll probably be a little bit different for when you're on Mars, because there's different particles that are on the different environments. and then also habitats for when you have the scientists that will be there one day, and figuring out how they're going to utilize the facilities in those areas and what's best used and what doesn't work.
Okay, let's see. Daniel wants to know, where do you see the future of NASA heading? How will our success of the Artemis missions change the world?
So a lot of the space program from Apollo days have changed. The technology we have learned and built and from going into space has changed the world. Now the way that we work through things, and like I said, from the 2030 timeframe, that's when we're looking to be expanding to Mars. Just like we did with Apollo, it'll take time and lots of missions to get there, to make sure that we're comfortable with our crew and the technology that we have. Once we learn from those missions from Artemis and then get a better feel from that, then there are plenty of other things that we can work to explore and gather more data on. There's looking at further moons on other planets and proceeding forward from there. But I do see that as being much in the future from right now. I would say probably the next 20-30 years is going to be focused on Mars, getting us Moon and Mars, and learning from those steps that we're taking right now.
All right, and it looks like from the rest of the questions that you have already answered most of them, either just now or through your presentation. So we'll use this next one as the last one. But Rebecca wants to know, and me too, honestly, what is the coolest part about working for NASA?
Oh, there's a lot of really cool parts. I think ultimately it's knowing that what I'm working on is going to be the foundation for the mission to Mars and beyond. That what I'm really working on is the direct implication of the success of those missions, and that astronauts will be on the hardware that I worked on. And I think that's the coolest part for me, working and doing what I do.
Awesome, thank you. And if you don't mind, I lied. We had one last minute question come in through Facebook. Jennifer wants to know, will they build a telescope at the space station on the moon?
I have not seen that in any of the mission statuses and objectives for there. I don't know, Patricia, if maybe you know a little bit more about the actual applications when they are on the moon in terms of telescopes.
Yeah, so I know they're going to use the moon to study the Earth and the solar. Oh, sorry. Thank you. I know that they're going to use the moon as a place to study the Earth and the solar system. I have not heard of a specific telescope that they're in production using, but I know that scientists and planetary scientists specifically want to be able to study the solar system and the Earth from the moon, even the sun, because there isn't an atmosphere to get in the way of any kind of telescopes or observations that we plan to do. We can also even look at study the moon and the space environment from the Gateway, which is going to be a spaceship that we keep in orbit around the moon to allow us to land on any part of the moon that we want to, and maybe even a stepping point from that Gateway to Mars. But we'll have to wait and see what types of telescopes we use, but I know there's going to be some sort of studying that takes place.
Okay, well, that's all of the questions that we have for today. Thank you so much for your time, Laura and Patricia. And thank you to everyone out there who's been watching. We hope you enjoyed this live stream and learned something new about NASA's Artemis mission. Have a wonderful day.
Thank you.
Between 1968 and